Alright, this is going to be lesson 3.2. I'm going to make this one quick because the last one I did, I recorded with no mic. I'm not going to have to waste like another 25 minutes doing this. But I am going to make it quick. I'm going to make it understandable, hopefully. Um, so do not question says, well, does my horizontal velocity change as the projectile is launched through the air? And what about your vertical velocity? So you can see from the GIF, you can see from the image that your horizontal velocity doesn't change. Your horizontal velocity doesn't change because, again, there is no acceleration due to gravity in the x direction. And in the vertical direction, you do see your velocity change. You do see as you go up, you slow down. And as you come back down, you kind of speed up, right? As represented by the vectors. So we can see here, right? I'm going to show you right now. Let's actually slow this, slow this. So let's zoom in even more, right? So as you see, so the y vector, the vertical vector is your vertical velocity, right? That's the length. But we're talking about the green line right now. So the length represents the magnitude of the velocity. So the larger the line, the greater the velocity. And so as you can see, as you go upward, as you can see, as you go upward, you see that your vertical velocity kind of decreases as you go up. Right? It decreases. And then what happens as you go to the middle point? Well, then your velocity now changes direction, right? You kind of slowly decrease your velocity up to the maximum height. And then what happens is that your velocity starts increasing back down because, again, you have acceleration due to gravity. Now, so there are a few assumptions you have to make. All right, so this topic is about assumptions that you can make about objects in projectile motion. So let's go through some of the assumptions, right? And so the first assumption you have to make is that, well, your vertical velocity at your highest point in your path is 0. So let's analyze that, right? Let's analyze that. So let's take a picture of this. So let's look at the horizontal velocity, right? So each of these points is like, well, a certain time, certain interval. So you can see that, well, your horizontal velocity in the horizontal direction, it's pretty much constant, right? We have a constant horizontal velocity because, well, our horizontal distance traveled each second is constant, is the same. But let's take a look at our vertical velocity. Right, let's take a look at our vertical velocity. So our vertical velocity. Let's start over here, right? Down here. You can see that as you go up to your highest point, right, as you go up to your highest point, well, your velocity changes and your vertical velocity changes up until you get to your maximum height. And at your max height, your velocity in the y direction is 0. And you're not traveling up anymore. And then once you get past your max height, well, now your velocity is negative because, well, now you're speeding it back up in the negative direction and you're coming back down. Right? And so this is the first assumption you can make, right? Your velocity and your max height is 0 in the vertical direction. And the second assumption you can make, well, your vertical displacement, once it goes back up to its launch height, well, if if you launch at a height of 0 and you land back at a height of 0, or if you land back at the same height, well, then your vertical displacement, right? Your vertical displacement is 0. Your vertical displacement is 0. Clearly, your horizontal displacement is not 0, right? Your horizontal displacement would be right here, and this would be dx, right? That would be your horizontal displacement. But clearly, your vertical displacement in the y direction, again, the y direction, is 0. And the third assumption you can make is that, well, the signs and the magnitudes of your vertical velocity are equal in magnitude but opposite in sign, in direction, on your way up and down, which makes sense, right? Because, for example, and I'm just making this number up here, or I will about to make the number up. Let's say, for example, you launch at an initial velocity of 50 meters per second, and that's upward. That's a positive velocity. Well, now you come back down, right? So you reach here, and then, well, your final velocity here would be negative 50 meters per second. Right? And so it's the same velocity except just different signs, right? It's the opposite sign. The same thing over here, right? So let's say my velocity here is, I don't know, 10 meters per second. Well, my velocity at the same exact point on the opposite side on its way down, well, it would be negative 10 because now the object is coming back down, right? The velocity of the object is now downward. Now it's moving downward, all right? So it's equal, but opposite side. And so the fourth assumption is that, well, your hang time. And so I can just explain it just based on this image again. If it takes you, I don't know, 5 seconds to go up, well, on its way back down to the from maximum height, right? Again, you're going up to your max height here. Well, on the way back down, it's gonna take you another 5 seconds to come back down. And that's just an assumption you can make. So if you say, well, your total time is 10 seconds, right? If your total time is 10 seconds, well, then up to max height would be 5 seconds and down would be 5 seconds, right? And so again, these are some assumptions you can make. And to summarize this, right? So variables and knowns on the path up have the same magnitudes as the path down. And this is what's known as symmetry of free fall, right? Symmetry, symmetrical. Things are symmetrical. And then the definition of symmetry would be, well, things are equal on both sides. So we can say that, well, my path upward, let me just screenshot this again. My path upward, right? So if we take our path up, right? Well, this path up would have the same exact values as our path downward. It would just be the opposite sign, except for time, right? So time would just be equal in both cases. So if you would take, like, I don't know, 5 seconds up, well, then 5 seconds down, well, it would take you 5 seconds to go up. It would take you 5 seconds to go up. So dy is 44.1 meters, and then dy down. So dy in this case would just be your displacement up to your max height, right? I'm not talking about your total displacement. I'm talking about your displacement up to max height, right? And your displacement back down, well, then that would be negative 44.1. Right? And so again, if we were to start with an initial velocity of 29.4 meters, well, then you're landing back down with a final velocity of negative 29.4 meters per second. And then if you were only taking the path up, well, your final velocity would be 0 on your path up, right? If you're only analyzing your path upward, your final velocity would be 0. And on the other hand, if you're analyzing your path downward, then well, your initial velocity would be 0, right? Because you're going from the top, you're going from max height to the bottom. And so the bottom would be a final velocity of negative 29.4 meters per second. And your initial velocity on the path downward would be 0. And so you can use either one of these. You can use this assumption to solve problems. Because when you're solving problems, you're either going to take your path up or you're going to take your path downward. So let's do this practice question right here. A ball thrown vertically upward reaches a max height of 30 meters above the surface of the earth. And at its max height, the speed of the ball is what? Well, you don't need anything, right? Because this is an assumption you can make. At your max height, your velocity of an object is 0 in the vertical direction. And so you can see that your max height is 0, right? That's that. Nothing else needs to be done. That's an assumption you can make. A ball is projected vertically upward from the surface of the earth with an initial speed of 49 meters per second. So this is your initial speed in the vertical direction. You know it's a vertical direction because it says vertically upward. So in your y-axis, you have an initial velocity of 49 meters per second. The ball reaches its max height in 5 seconds, right? So that's dy. So dy is 5 sec. I'm sorry, t. Your time is 5 seconds. It reaches its max height. And so what's its max height reached by the ball? Well, dy is question mark. Well, you need another known here. Well, an assumption you can make is that what at your max height, your velocity at the top is 0. So which formula are we going to use here? Also, there's another assumption you can make. Well, your acceleration due to gravity in the y direction is negative 9.8 meters per second squared. Since we have 4 knowns here, we can actually use 2 formulas. We can either use this formula right here or this other one right here. It's on your reference table. So dy, we're looking for dy. We have vyi, we have t, we have a, and we have t. On the other hand, on their form, we have vyf, we have vyi, we have a, and we have d. Alright, so you can use either formula. I'm going to use the first one, or rather the second one if you think about it. dy is equal to 49, 5, negative 9.8. $49 times 5, 98, 196, so 200, 245. 1/2 times negative 9.8 gives you 4.9. 5 squared gives you 25. This gets you 122.5. And now you get 122.5. Alright. Seems about right. So your max height reached by a ball is 122.5 meters. Alright. So 2C, this question is a bit trickier. So this question says the basketball player jumped straight up to grab a rebound. And says if she was in the air for 0.8 seconds, well, how high did she jump? Now, this question is phrased very specifically, right? It says that you're in the air for 0.8 seconds. And so, well, how high did she jump? Well, if if your total time is 0.8 seconds, well, it takes you a time of 0.4 seconds to get up to your max height and a time of 0.4 seconds to come back down. So your total time will be 0.8 seconds. Well, the question is saying, well, how high did she jump, right? So they only care about max height here, right? So they only care about max height. And we know our acceleration in the y direction is negative 9.8 meters per second squared. And so we know that if we're solving for our path upward, then our final velocity at the top would be 0. If we're solving for a path downward, our initial velocity at the top would be 0. So, right? So I'm separating this into two sections. So we can either solve for our path upward, or we can solve for a path downward. But you can use either side, right? Because both sides are symmetrical. Symmetry of freefall. But if we were to solve for our path upward, if we were to take these 4 variables on our left-hand side, there is no formula that contains our 3 knowns and dy, right? Because we have vy, ft, dy, and ay on our left side. If we take a look at our formulas, we don't have vyi here. We don't have vyi. We don't have vyi. So we can't even use these formulas to solve for the left side. But on the other hand, we can solve for our path downward. Because on our path downward, we have vyi. It's 0. Our initial velocity in the vertical direction is 0 here. So we can solve for our path downward. And so now with these variables we have here, we don't have x there. We have everything, right? We have this, 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 and this. So we need to solve for a path downward instead. Because everything is equal, it's symmetrical, it's just going to be the different sign. Right, so dy is equal to vyi 0 plus 1/2 negative 9.8 t squared. So dy is equal to 1/2 times negative 9.8, negative 4.9, 0.4 squared, 0.16. This gives you negative 0.784 meters, which makes sense because, well, she from the top to the bottom, you have a negative displacement, but she jumped 0.784 meters high. All right. Uh, 2D is the same exact type of question as 2C, right? You have to divide your time by 2 because, again, it's saying the total time she spent in the air is 3 seconds. And you are going to solve for your path downward, right? You have to do the same exact thing. You solve for your path downward. All right.